All right, we're just going to keep going through some examples because these take a lot of practice. So in this one, our focus is at 5, -1, so that's somewhere around here. The directrix is at the line x equals -3, so I always think the y values can change, but x always has to be -3. That's how I know it's a vertical line. So from here, I can see that it should open to the right. And I know if it opens to the right, that means the y value is the one that's squared. So now I check what's the distance from the directrix to the focus. Horizontally, it's got a distance of 8. So that tells me that P is going to be 4. And again, because it's opening right, it's going to be a positive 4. To find my vertex, move left 4 from the focus. So that means your vertex is going to be at 1, -1. So that's right here is your vertex. And when we write our equation then, so the y term is the one that's squared. So we end up getting y plus 1 squared equals 4p. Our 4p value would be 16. So 16x minus the x coordinate, and that is our equation. Again, this is another one you'll have to be very, very careful when you plug it into your calculator to find the values for that. All right, so this one, our focus is at -2, 0. And our directrix is y equals 4. So that's this one right here. So I can see it should open down. If it's opening down, I know that my x values are ones that are squared. Now I check, what's the distance? What's the distance between my directrix and my focus? It's got a distance of 4. So my p is going to be half of that 2, but I have to think it's opening down, so it's going to be -2. So now I know I need to move up 2 from the focus to get my vertex. So my vertex should be at -2, +2, and I can write my equation. So my x is the term is the one that's squared, so it gets me x plus 2 squared equals 4p. My 4p value should be -8, y minus the y coordinate. So that is our equation. So now what happens if we're given the expanded version? It's very similar to what we did with circles, except this time we only complete the square of the squared variable. You only have one variable that's squared, so that is the one that we will complete the square with. So isolate the x terms, move everything else to the other side in this case since we have x squared. Completing the square, add 4 to both sides. Once you get to this portion where you've got your perfect square on the left and then you've got your pieces on the right, you should be able to factor something out. So whenever you have that factor you pull out, remember that's your 4p value, okay? So here that 4 in front is 4p, 4p is 4, so p is 1. Our vertex should be at 2, 2, based on those values there. So once you've got your vertex at 2, 2, your p-value is 1, your focus is going to be up 1, your directrix is going to be down 1. So we've got our equation here. So we look at which term is our squared term. It's the y, so that's what we need to isolate. We isolate the y terms. Now we have to take our b over 2 term. So our b is 8, so we add 8 over 2 squared to both sides. So we're adding 16. They've already done it in a step here. So they took -18 plus 16 to get -2. We take our perfect square. We get y plus 4, our b over 2, minus 2x minus 2 still. And then on the on the right-hand side, we can factor out a -2. So we still have x plus 4 on the left. We factor out a -2 to get x plus 1. So we identify these key features from our equation that we have. 4p is -2, which means p is -1/2. H is -1, K is -4. So our vertex is going to be at -1, -4. Focus, well, let's take a look. We know it's a y squared, so it should be opening left or right. Since P is negative, it's going to open left. So that means our x values are changing. So we're going to subtract 1/2 from our x value to get -3/2, -4 as our focus. The directrix, then we're going to move to the right. So we take our x value and add 1/2 to get our directrix at -1/2. Now I did a bad job and I didn't plot all of these, but we can still see the important bits. -1, -4 is our focus. Sorry, our vertex. Focus is at -3/2, -4. This is really hard to see with the scale. And then the directrix is at x equals -1/2. So we need to convert this equation. So we look at which term is squared. It's the y's. So that's where we have to complete the square. So we have y squared minus 4y is equal to positive 12x minus 64. We add our b/2 term, which is going to be 4. We add that to both sides. We get our perfect square on the left, so it'll be y minus 2 squared equals 12x minus 60. We factor out what we can on the right, y minus 2 squared, and factor out the 12, and we get x minus 5. So from here, what do we know? We know the vertex should be at 5, 2. We know that 4p is 12, which means that p is 3. We know that it's y squared, and we know that p is positive, so that's telling us it should open to the right. So since it's opening to the right, our focus would be p distance to the right at 8, 2, and our directrix is going to be the line x equals 2. So we plot our vertex, it's at 5, 2. Our focus is at 8, 2, and our directrix is the line x equals 2. Again, you can plot those other points you can find by putting your equation into your calculator. Again, very, very carefully. So this time our x terms are squared, so we'll move everything else to the other side. And then we will complete the square on our x's. So our b divided by 2 terms squared is going to get us a 16 there on both sides. Our perfect square, we're going to get x plus 4 squared equals 16y plus 64. We factor out what we can on the right, which is a 16. We're left with y plus 4. So now we analyze. So our vertex is going to be at -4, -4. We know that 4p is 16, so p is 4. Now we notice our x terms are squared and our p is positive, so that's telling us it's opening up. So for opening up, our focus should be p terms up, so that would be at -4, 0. Our directrix is going to be down 4 terms, so it's going to be the line y equals -8. So our focus is at -4, -4. Sorry, our vertex is at -4, -4. Focus is at -4, 0, and the directrix is that line there at -8.